Hey everyone, and welcome. Today, we are going to tackle a classic, super useful task, adding a brand new hard drive to a Linux system. We're going to take it from just a piece of raw hardware all the way to fully usable space. So let's get right into it. You know the feeling. We've all been there. You're right in the middle of compiling code, downloading a huge file, whatever, and bam, your system just screams at you that it's out of space. It's so frustrating, and it can bring your entire workflow to a grinding halt. But what if you could just make that problem disappear? Well, guess what? You can. Today, we're going to take that exact frustration and turn it into a total victory by installing a brand new hard disk, both physically and, more importantly, logically. Now, we're going to follow a really clear four-step journey. Think of it as our roadmap. First, we got to find the new disk. Second, we'll partition it, which is like drawing rooms in a house. Third, we format it with a file system. And finally, fourth, we'll mount it so our system can actually see it and use it. Ready? Let's go. Okay, so you've physically installed the drive. You've plugged it in. The very first thing we need to do on the software side is to check if our Linux system can even see this new piece of hardware. We have to identify it before we can do a single thing to it. To figure out what's what, we're going to use a fantastic command, lsblk. It literally stands for List Block Devices. And it gives us this beautiful, clean tree view of all the storage attached to our machine. Okay, check this out. You can clearly see SDA up top. That's our original 20 gig disk. It's got partitions, they're mounted, everything's working. But look down here. See this SDB? A 2 gig disk with absolutely nothing under it. That, my friends, is our new drive, a completely blank slate. So a raw disk is kind of like an empty warehouse. It's just one big open space. Before you can store anything in an organized way, you need to put up some walls and create specific rooms. In the world of disks, we call this partitioning. And our tool for this job is the legendary fdisk. It's an old-school, super powerful utility that gives us total control. We're going to point it directly at our new disk, which the system has named /dev/sdb. The sequence here is really simple but absolutely crucial. Once you're inside fdisk, you press N for a new partition. We'll just accept the defaults to use the whole disk. But remember, nothing is permanent until you press W to write the changes. That's the most important step, the point of no return. Okay, we've told the system to create the partition, but did it listen? Let's run our friend lsblk one more time and see if you can spot the difference. And there it is. A perfect success. Look closely at SDB. It's not alone anymore. It now has a child element nested underneath it, SDB1. We've successfully created our first partition. Our warehouse now officially has its first room. Now, having a room is great, but it's just an empty box. To actually organize files in it, we need to install shelves, filing cabinets, and some kind of addressing system so we can find things later. This is exactly what a file system does for a partition. To do this, we use the mkfs command, which literally means make file system. Or choosing XFS for this one, it's a really robust, modern file system you see in a lot of enterprise systems. Another popular choice is ext4. We'll just point the command right at our new partition, /dev/sdb1. Now, this block of text might look a little intimidating, but don't worry. It's really just the system reporting back all the technical details of the file system it just built. The most important part? It completed without any errors. Our digital shelving is now officially in place. So, just to be crystal clear, what is a file system again? It's the fundamental structure, the blueprint that your operating system uses. Without it, a partition is just a sequence of totally unusable blocks. It's the logic that turns raw space into organized, usable storage. We are on the home stretch. We have a partitioned and formatted drive, but right now it's still kind of like an island, disconnected from our main system. Mounting is the final act of connecting our new storage to the main directory tree, making it accessible to everyone and everything. Now, we want our drive to be available every single time the system boots up. To do that reliably, we need a permanent, unique address for our partition. Think of it like a serial number that never changes. We can find this using the blockedD command. And here we go. The blocked command lists all the blocked devices and their properties. And right there at the top for /dev/sdb1, you see that long string of letters and numbers labeled UUID. That is our partition's unique fingerprint. We're going to go ahead and copy that. So why go through all this trouble? Well, the device name dev/SDB1 isn't guaranteed to stick around. If you plug in a USB drive or add another disk, our new drive might suddenly become dev/SDC1. The UID, however, is tied to the file system itself and will never, ever change. Using it is simply a more robust, professional way to manage your disks. So where do we put this magic UUID? We add it to a critical system file called /etc/fstab, which stands for File Systems Table. This file is basically the instruction manual that Linux reads at boot time to know which disks to mount and where. We're going to tell it to mount our new disk at the /home directory. Take a look at that last line right there. That's our new entry. It looks a little cryptic, but it's simple. It says, hey Linux, take the device with this specific UUID, mount it at the /home directory, recognize that it has an XFS file system, use the default options, and don't worry about those last two numbers for now. We've edited the instructions, but we haven't told the system to reread them yet. The command mount-a does just that. It tells the system to mount everything listed in our new and improved etc/fstab file that isn't already mounted. This is the moment of truth. And for the final check, let's look one last time with lsblk. Look at that. It's beautiful. The final piece of the puzzle is in place. Right next to SDB1, it now clearly says the mount point is /home. We did it. We took a raw piece of hardware and turned it into a fully integrated, usable part of our file system. So there you have it. We transformed that disk-full error into an opportunity. We've added capacity and control. But the key takeaway is this isn't just about storing more files. It's about creating more potential. So the only question left is, what amazing things are you going to build with all that new space?